So what's behind the scenes? What does the architecture look like, and what are the components within Microsoft Copilot in general, right? So first things first, the architecture. Now, for Microsoft Copilot, as you can see here, I hope this is visible, is that first of all, everything that happens with your Microsoft Copilot happens within your service boundary. Your data never leaves your organization. Now, very important point here is that there's a lot of customers, there's a lot of people who would say that, hey, we do not want AI in our company, we do not want LLM structures in our organization. Why don't we want them? Because it's going to be reading our data, and they're going to be training our LLMs they're going to be training their LLMs, the OpenAI, Microsoft, and whoever else the vendor is. They're going to be training their models on our data. That means it's not safe. No, not really. Your data would never leave your organization. You see here, Microsoft 365 service boundary. That means this is your organization. Everything that's dotted here, that's this shape, anything that's inside of this is inside of your company. It never leaves your company, right? Now, this is the user. User sits conveniently outside of the organization. Can be inside, but it's basically a request that's coming from outside, coming from the internet, or maybe coming from a third party. So whenever, as a user, you make a request to Copilot, you're just typing in a prompt, and same process happens with ChatGPT, by the way. It does not change anything. The basic process is still the same. Same thing happens with Perplexity as well. By the way, a similar thing happens with Perplexity. Now, when there's a user on the outside, they are trying to make a prompt. They want to do something very specific. What's going to happen is they're going to ask the Copilot, right? They're going to type into Copilot certain sort of a prompt. What happens then? Then this Copilot starts. Okay. Now, how does this go? First of all, user prompts are sent to Copilot. From outside, the user prompts are sent to Copilot. All the requests would be HTTPS enabled. All the requests will be encrypted in that nature, right? Second thing is what happens, the process called grounding. User delivers a prompt. User says that, hey, this is what I want to do. This is my request. This is my prompt. Assuming that we understand what a basic prompt is right now, maybe we can do another video later on to explain what a prompt is and what kind of prompts there can be. But user makes a prompt and it goes to Copilot that's within an organization, right? Now what happens here is that because Copilot is within the organization, the Copilot needs to see that prompt and figure that out and add some context to it. If you say something to me right now and it's out of context, something out of the blue, I would not even understand it, right? If it's in context of this training, you ask me a question about Copilot or make a comment about Copilot, it would make sense. If you say something about classical music that's outside of context, I would not be able to answer you. Same thing. If the Copilot has context, it will be able to answer better. If it doesn't have context, it will give you any kind of garbage that it can find. And that's what happens with these LLM models. Anyway, this is not just the LLM, this is the Copilot orchestrator right here. So, user makes a prompt, comes to Copilot. Copilot does a process called grounding. What does grounding mean? Add the context to the information that has been received from the user. Now, what will happen is that Copilot will check various data sources, whether they are third-party data sources, could be Power Platform, could be a third-party data source like your Salesforce, could be something like ServiceNow, any third-party applications that you have connected with Copilot. Anyway, you can connect third-party applications with Copilot as well, right? And you have connectors to do that, and you have plugins to do that. Anyway, you can do that pretty easily. Now, these plugins and these connectors would add your third-party applications here, and all that data would get indexed into something called as Microsoft Graph. All the information that that Copilot is going to receive, your files, your folders, your emails, your contact details, the files associated with other users, the data that's going to come from outside, that will be staying within the context of your organization. It stays with Microsoft Graph, and Microsoft Graph does one process, and it does it really well. It makes the connectivity. It makes the connectivity with the third-party applications, make the connectivity with the APIs, right? So it does the process of grounding. So first step is user prompts are sent to Copilot. Second step is Copilot accesses the graph and figures out, for example, let's say a user talks about a user ticket, right? I have this user ticket 7827, and for this particular user ticket, I want to get more information. That's the prompt from the user. Copilot does not know what 7827 means. Copilot does not even know what ServiceNow is. So Copilot is going to see in Microsoft Graph that, hey, do we know something called as a ServiceNow? Do we know something that's called a ticket number 7827, let alone what's inside of it, right? So Microsoft Graph needs to know or needs to have that information for Copilot to be able to actually retrieve it. If they can't retrieve it, it won't happen. It just doesn't work like that, right? So Microsoft Graph needs to have that information. So this grounding process can happen at various levels. It doesn't need to happen just for these third-party applications and for internal resources. It can also check the web. It can also check any context that you have provided, right? So that's the context part of it. Now the next part is, once all the information is gathered, based on the prompt that the user made, based on the information regarding that prompt that was available in the Microsoft Graph and the third-party application, everything else is combined. This is a really beautiful process. Now everything is combined with Copilot, and Copilot sends it now to the LLMs. Copilot sends it now to the LLM, to the models, to the large language models that we have here. So your data, before it even goes to the LLM, most of the process is already done. The searching, the idea of looking for things, locating them, add some context to it, Copilot has already done that. Then that information would move into the LLM, to the large language model. Large language model would change that information or would try to interpret the information that the user sent, whatever the prompt was there, whatever the information was here from the Microsoft Graph. It will combine that information and it will give it in a user-friendly manner, right? So Copilot would be sending this modified prompt to the large language model. Now, quick detour here. This large language model could be from anyone. It doesn't mean that you need to use the Microsoft ones, OpenAI ones. You can bring your own model. You can use a custom model in Copilot. You can use a model from anywhere that you may have trained, right? Really important things that whenever you're training a model or whenever you're getting a model, make sure that it follows this. It follows RAI or responsible AI, making sure that the model is trained in an ethical manner, trained on the data that's responsible, and it's going to act in a way, well, like a civilized human would act. You would not want your AI to go absolutely berserk and give you answers that would basically embarrass you, right? You do not want that to happen. And you do not want the data to be biased. You do not want, because this LLM is trying to make sense of data. It doesn't have any data of its own. It's not producing any data. It's trying to make sense of what it gets. So you want that to make sense. So these models can come from OpenAI. They can come from Azure. They can be your custom models as well. So once the modified prompt is sent here, what happens next is this will compile all the information, send the information the way that it's supposed to be sent to the user, and then the information is given to the Copilot orchestrator. This center Copilot logo is the orchestrator right here. The information goes to the orchestrator. The orchestrator receives the LLM response. Now, it could just give it straight to the user. No problem. Could have been done. But that's not the best thing to do right now. You want to make sure that the user who's asking for that information is supposed to... You want to make sure that the user that's asking for that information is eligible to get that information or not. Has the security policies in their favor or not? Have the right access or not? All that would have to be checked in the next step. So Copilot accesses the graph again for the compliance and for purview to make sure that the information that we are providing to the user is in fact something that we can provide or we should not be providing, right? So that decision is made right here in point number 5. And once this decision is made, user makes a prompt. The prompt goes for grounding. Grounding happens. A modified prompt is sent to the LLM. LLM gives a response back to the orchestrator. Orchestrator sends it to the Microsoft Graph for compliance and purview. And then once compliance and purview is done, finally, the user is going to get the response back from Copilot that, hey, this is what you asked for and this is the information. Now, this answer may or may not be the best one. There's a lot of moving parts here, right? And I'll talk about those moving parts in a minute as well. But finally, these are the 6 steps. If you're thinking Copilot, if you're thinking ChatGPT, if you're thinking any sort of an LLM model or any sort of an LLM orchestrator like this, the process would more or less be the same. User makes the request to the orchestrator, orchestrator checks the data sources, then a modified prompt is built. It's then sent to the LLM, making sure, really important, making sure that this LLM and the data sources do not have direct connectivity with each other. You do not want this LLM to train on these data, on these data sets. And LLM is like, why would it talk to your data sets anyway? So that's where the orchestrator draws the line, right? And this process is basically would move us into something called as RAG or RAG, right? Anyway, so this is a 6-step process. Once you understand this for Copilot, you can understand this for ChatGPT, you can understand it for basically pretty much any such system. So with minor changes, they are not exactly the same, but they're very, very similar, right? So now, I hope this is clear. And now, like I said, the answer that you get in 6, the quality of that answer would depend upon 3 really important factors. What 3 factors are there? First factor is what kind of a prompt has the user sent. If it's a good prompt, it's a bad prompt. Now, the thing is, the quality of answers you're going to get, and this is not just AI, this is not just LLMs, this is your life. The quality of answers you're going to get will be almost directly proportional to the quality of questions that you ask. If it's a shitty question, it's a bad question, it's not going to work out well, right? It's not going to be able to comprehend it. So you want the prompt to be as detailed as possible as user. Give it context, tell the LLM how you want it to think, tell the systems how you want them to think, what kind of context is there, what information do you want to compare it with. So be very, very rigorous with the information that you provide. The more detailed your questions are, the better your answers will. So that's point number 1. Point number 2 is what kind of data that you have within your organization, or what kind of data that you're retrieving context from. If that data is incomplete, if a user is looking for a ticket number 7827 that's on ServiceNow, and ServiceNow is not even connected to Copilot, there's no way in hell that it can find an answer for you. It will not work. So you want the prompt, the data to be great. And what's the third part? Third is the really important one, which people stress a lot about, and they should, is the LLM. If the LLM is not well trained, if the LLM is not ethical, it's biased, it hallucinates very much, it hallucinates a lot, it's an incapable LLM, it's not like the newer ones that we have been getting in the last 6 months to a year. It's not going to be able to make sense of how well your prompt is written or how good your data is. So you want the data, the prompt, and the large language model to be absolutely in sync and to be absolutely of the highest quality that they can be. If they cannot be like that, that's fine, but do not expect that kind of a system to perform at a top tier, right? So by the way, once you add your sources to Microsoft Graph right here, it might take a few days for indexing to actually work. And Microsoft would give you technically a notification that, hey, your indexing is now complete, or your indexing would take a certain amount of time. At this point, while we are shooting this, Microsoft does not give you a specific timeline of that, hey, this is going to get indexed in about 2 days, 3 days. Usually that's the amount of time that it takes. And there's user level indexing and then there's tenant level indexing, but that's for another discussion. And I know this is a space that changes quite a bit every few months. So even by the time that I post this somewhere, or even by the time that some of you are taking a test or something like that, these things might just change. So feel free to put those updates in the comments so that we can update the video accordingly and we can keep it current. Thank you so much. And yeah, that was it. Thanks.